Seeking English, S.A.T. Workbook, page 467, problem 4. This is one of my favorite problems in class, but it is not one of my favorite problems for trying to make a video about it. So if it seems like the video ends abruptly, right where all the tedious calculation is about to start, yeah, okay. It says you can use a calculator. I'm going to get to a point in the video where I say, now use your calculator. And then we're basically going to stop there. Okay, in the meantime, it says, they gave you this formula, h equals minus 16 t squared plus vt plus k. Okay, does that look like anything to you? Sadly, to a very large number of my students, that does not look like anything in particular. Okay, if it did, more of them would be well prepared for the rest of the problem. It says, the equation gives the height in feet of an object launched straight upward at an initial velocity of v feet per second from a height of k feet above the ground. If the object is launched upward at a velocity of 100 feet per second from a height of 25 feet above the ground, after approximately how many seconds will the object hit the ground? And thank goodness they gave you 4 answers to choose from. Okay. Okay. If you were completely stumped by this problem, I would again suggest what I mentioned in some other videos, that if the answers are in numerical order, as they are here, and you are looking for a solution rather than a non-solution, and the test does ask you for non-solutions, which thing doesn't work. If you're looking for a solution rather than a non-solution, there's a small statistical advantage to the inner answers, and you don't have to believe me. You can check for yourself what is the distribution of such answers on which such types of questions. In this book, in practice tests, etc. I think inevitably you're going to agree that there's a small statistical advantage, but it is very real, that if something's a solution, it's more likely to be answered B or C. If it's a non-solution, it's answers A and D. This is not superstition. There's a good logical reason for this to be true of test design, not only on the S.A.T. but also on other standardized tests. And I've talked about it enough in other videos. I'm not going to go over it in this one. Hopefully confronted with a problem similar to this on the real test, you will not resort to that. Or if you do resort to that, okay, hopefully you will not. If you do resort to that, hopefully you'll have a chance to come back. You have a chance to come back and figure out what went wrong. So what could go wrong? There's enough to do in this problem if you get past the basic point of confusion that stops most students, which is this H here. And if it already seems obvious to you watching the video, that's great. Somehow, if you come and take the class with me, you will forget that it was obvious, because it's not obvious to most of my students. It's obvious to a very small number of them. And usually the hint that H is something specific relates to the shape of the formula, giving them a hint. So, and if you ever have taken a test and as soon as the bell rings, you realize, oh, that was the solution to that problem that I didn't solve, and I can't solve it. This would probably be a good example of that type of a problem, where as soon as the bell rings, within a minute or two, you start to realize, oh, H was that thing, because that was okay. Yeah. So is there any strategy? Is there a plan you can follow not to get stuck on points like that? Not much. One is doing a lot of problems, just so that you can focus on answering the weird question and without also having to juggle all these other things, which you can do more automatically. Another one is habituate yourself to look for hints or clues that the test designers have put into the problem, and they do that a lot. When you've looked at these things enough, you realize test designers love to give you hints. They love to give you subtle suggestions. Okay, and depending on your idea of subtle, what's subtle about this one is this is definitely this is a quadratic. Okay, if you didn't spot it as a quadratic, that's okay. Most people in my class also don't, or if they do, they're not sure what to do with it, just because it seems like there's too much going on in this problem. But let's start to do what we know we inevitably have to do or should do, and see what else falls into place. Sometimes if you start working on it, things begin to make sense. Are we solving for the H? Are we solving for the T? Are we solving for the V? Or are we solving for the K? Well, for sure, we're not solving for the K because they gave us the K. Okay. for sure, we are not solving for the v because they gave us the v. Okay. Now it says time. We're looking for the elapsed time. Would that be the t or the h? T or the h? Well, t sounds more like time. Yeah, could that be it? Well, what else is involved? What else is involved? The story says that this object is launched, and as described in the problem, seems to be a passive object launched through some kind of launch mechanism. And I don't think any student has been confused by this in my class. I was very confused by this the first time that I read this problem, because it describes the thing going straight up in the air and then coming straight down. But when it comes straight down, it hits the ground. So whatever launched it, I guess, isn't there anymore. Whatever the launch mechanism was, or launch surface, or it confused me. It was enough to confuse me and waste a little bit of my time. So if it also confused you, I think that makes two of us now. In the meantime, I'm going to show you a slightly altered version of this story that makes it easier for me to make sense of it in class, although it does arguably diverge from what's literally given to you in the problem. The math is the same. Okay, you have a launch surface, something that is 25 feet there. Okay, it's launched not perfectly straight up, but over here. Okay, it passes this point of 25 feet. And it comes down to the ground where it stops. Okay, don't worry about the complex physics involved, because all you have to do is get rid of three of these bad answers, or in this case, actually maybe just solve. Just pick one of these answers as being closest to the correct number. Okay, so either the h is the height and the t is the time in seconds, or the t is the height and the h is the time. What does it say in there? It doesn't really, I've looked at this again and again. It's a little bit confusing just because they don't really spell everything out for you perfectly. I'm going to tell you that if we look at this as a quadratic and we think the h is probably a 0, would they give us a hint like that? Yes, they would, because they want to make it practical for a normal student to be able to solve this in a normal amount of time. So yes, that is a hint that they would give you, and in this case they did give it to you. So if that were 0, then we'd be solving for t, which is time. If you decide that the h is the time, okay, then what happens to the t is really weird, because the height over here, when it hits the ground, should be 0, and that would negate all this, and that doesn't match. It just doesn't match. So hopefully that wouldn't occur to you. It wouldn't occur to you that there's a way to get it wrong like that. Hopefully your intuition would serve you in seeing beyond possibilities that only occur to me. Okay, so the h is 0, and students get confused by this because they're not visualizing it like this. The question of what's the height when it hits the ground. Somehow I can ask that question of some students, like 5 or 10 times, and it still doesn't somehow sink into them that when an object hits the ground, its height above the ground is 0. Okay, that's the thing where after the test is finished, you realize, oh, okay. So again, you can't. There's no strategy for defeating that kind of a mental block that catches you in the middle of a problem, but otherwise would not catch you. The strategy for getting around it is to look for any hint that they've given you just in terms of the shape of the formula. The hint that h is 0 helps, because if you guess h is a 0 and you think, what would that mean? Height is 0? Oh yeah. You kind of reverse engineered the question. Okay, hopefully. I know I'm explaining this a lot, but it's amazing how complicated this problem actually turns out to be in class, and from how many different angles I have to explain it again and again and again. And I confess that I kind of enjoy that. Okay, so they did give you 0, although they did not call it 0. The only thing that you could possibly be solving for is this t. And as I said, it is a quadratic. Okay, there's your t squared, here's your t, your x has become a t. Okay, and this is, I'm going to call this T1 and this is T0. So if your algebra teacher is watching and they see this part, great. I love to call it T0, T1, T2, or X0, X0. Right? There. So for me, that makes better sense. But the important point is, that's really the tough conceptual part. All that's left is the calculation. So I'll take you to the next step, and I'm probably going to stop punching in your calculator. Okay? T, the thing that we're solving for, equals minus b plus or minus square root of b squared minus 4ac over 2a, and I have deliberately not left enough room for myself, so I have an excuse to not put everything through and calculate it for you. I will help you this much. Minus 16. The minus is crucial here. Minus 16 is your a. Okay? I know uppercase, lowercase, I don't care. Okay? 100 is your b. Okay? And 25 is your c. And if you plug those in and play with it, it's going to take you longer, okay, than most problems will. And from the beginning of this problem to the end of this problem, even if you know what to do in advance, it will probably take more time than you would allocate for an average problem on the test. That's probably why it's problem 4 on this page. Okay, so take your A, your B, your C, put them through here, and it's a lot of work. You want to see it? You want to see me do it? You have to sign up for the actual class. I will do it. I've done it hundreds of times. I have witnesses. Okay, and it should take you close to this answer, which, hey, it's one of the inner answers. Yeah, not very surprised. Okay, so students have various emotional reactions to this problem, regardless of how well or badly it goes for them. So if you have any comment, even if you're furious at me for the way I've explained this, go ahead and say so in the comment section. I'll be very, very happy to answer any questions about this problem in the comment section. This is one of my favorite problems.